you should definitely start thinking that it's possible to automate cloud architecture, software architecture design using LLMs, for instance, Claude Code, because without that, you will stuck in a situation in which you won't be able to speed up the process 5 or 10 times, because the quality of the engineering tasks will be low or moderate quality, and you will need many manual processes to bring from this moderate quality to the high quality. Yeah, the code won't be secure, the code won't be cost optimized, because the design is critical. So you should start thinking that design can be automated using LLMs, because without that, we won't be able to design any solution that is possible to allow you to speed up the process, and in such way that you will think that it's possible to automate the architecture generation. We're gonna think about how it's possible, how we can design the methodology, how we can use Claude Code doing this. And this is critical, that we should start thinking that it's possible. And in this series, I will show you that definitely it's possible, but of course it's not easy, but it's possible. So if we are thinking that it's impossible, we won't be able to do anything, because we will think that it's impossible. So start thinking it's possible. So in this series, I'm gonna show you how using Claude Code you can automate cloud architecture generation, and we'll talk about GCP, but of course these same patterns can be used to generate AWS architecture generation or Azure architecture generation. Okay. So the methodology that I've created is based on Claude Code, and in the next episode, I will tell you why Claude Code, and I will explain all the elements of the methodology. But now I'm gonna tell you a few things about this methodology. So this methodology is based on the advisory files. So this is the brain of the whole, tool, and it's very important to understand that LLMs by itself cannot be used to generate good quality architecture, because the documentation, so the documentation of the cloud providers is very low quality. So this is a problem, because the LLMs like Claude, Gemini, ChatGPT, DeepSeek cannot understand, for instance, networking of the cloud, so they cannot produce high quality architecture. So the advisory files are the files in which there is a knowledge of, for instance, senior cloud architect or consulting companies that have many years of experience in the cloud architecture and cloud engineering tasks. And they know that, for instance, when you are talking about Composer, you should think about A, B, C. When you are thinking about BigQuery, you should think about D, E, F. Yeah, and this is a knowledge that is not in the documentation, because the documentation is missing real cases, is missing important things that they know. Yeah, the cloud engineers, the cloud architects, the consulting companies that have many years of experience in cloud computing, they know what you should think about when you are talking about Vertex AI. So how you should design the network behind the scene, how you should design security things. Yes, so for each technology, for each service, like Composer, BigQuery, VP Service Controls, Private Service Connect interface, Vertex AI, Gemini Enterprise, what you should care about, what you should think about when you are thinking about Composer and networking, what you should think about when you're thinking about Composer, how to connect Composer, for instance, to Artifact Registry, how to use Vertex AI pipelines, how to use Vertex AI Feature Store, and other things. Yeah. So these advisory files is the brain of the tool, and it's hard, of course, to design such advisory files. But I will show you how it's possible to use such things to fit the Claude Code. Yeah. And I'm gonna show you how this can speed up the process of the design and the quality of the design. Okay, so this is the brain. So the advisory files is the brain of this tool. And also, we need to think about the context of the landing zone. The landing zones, in the next episode, I will show you why the landing zone is important and why you should divide, of course, the landing zone concept and the solution teams concepts. So essentially, you have the landing zone, and every landing zone has specification, should have specification. Yeah. So in this specification, you should find the network topology, you should find the security things, how the IAM works, what are the organization policies, and etc. How, for instance, things like Docker images or Python images, how this should all works. Yeah, where I will find the, for instance, Python packages in the artifact registry, or maybe in the artifactory, or maybe somewhere else, how this should be all connected. Yeah, so in the next episodes, I will show you the definition of the landing zone and how this landing zone specification should be defined. And also, in this landing zone level, you have something like architecture decision records. So these are documents which will document the most important decision regarding the landing zone. So why the network topology looks like it looks. Yeah, why the security things are designed that in such way. Why alternatives was not proceeded. Yeah, so this is important thing, because without that, the LLM cannot understand the context of the landing zone, and with that, the Claude Code will be able to tell you how you should, for instance, attach the composer to the landing zone from the network perspective, yeah, from the DNS perspective. He will understand that because he will know how the network topology is designed, how the whole landing zone is designed. Yeah? And also, of course, the landing zone is critical, but also you have this solution things. So you have solutions. So these solutions are the, for instance, teams inside your company which are doing something. Yeah. So this can be a team which is developing application. This will be can be a team which is developing data pipelines. This can be a team which is developing AI solution. Yeah. So we have different solutions within your GCP environment, and this should be divided from the landing zone. And in the next episode, I will tell you why it should be divided and what is the landing zone, what is not the landing zone, and each the solution. So for instance, if a team is developing data pipeline using Composer and Airflow, yeah, this solution has context. Yeah, so in this context, there are different things related to requirements, the context of the product, the context of the team, the context of the standards within a team. Yeah, so all the things related to the solution. And also in the solution level, also we have this architecture decision records. So when we are thinking about why we are using Composer, not Scheduler, why we are using BigQuery and not Dataproc, why we are using, for instance, Vertex AI pipelines, why we are using, for instance, Cloud Run and not GKE. Yeah, so all the things related to that why we are doing something, why we are designed this solution in such a way, we should document this using these architecture decision records. Okay, so we have the landing zone, we have the solutions, we have the advisory files, and also we should have the context of organization. So in this context, we should find the organization standards, and we should find the CMDB. I will discuss this later. And in the end, of course, in the cloud engineering work, we have these Terraform modules, and I will tell you how good quality Terraform module should look like. And I will tell you how this Claude Code can generate high quality Terraform modules which are compliant with your landing zone, which are compliant with your solution architecture, which are compliant with your all requirements and all organizational standards, and the context, which is mostly visible in the CMDB. And this is something that you can do that, but you must believe that you can do that. And also this tool can generate not only Terraform modules. This tool based on Claude code can also design, for instance, diagrams. It's possible to generate high quality diagrams if you will advise Claude code how this tool should do that. Because of course, without advisory files, in the advisory files there will be also things related how the diagrams should be designed. And if you will tell Claude Code how Claude Code should design and diagrams, he will do that. But of course, he needs good quality instructions how to do this. And of course, this Claude Code, as the outputs, will generate diagrams. He will generate architecture decision records and Terraform modules. So so in the end, about the feedback loop will look like that, and this tool will update the architecture decision records, the landing zone specification, of course. He will update the architecture decision records and solution context in the solution level, and of course update the Terraform modules. So this is definitely something that is possible. And in the next episode I will show you how the whole process should look like, and how in practice we can use this tool to generate high quality cloud architecture. And of course, this is important that this tool, this is the tool that you can design also by yourself, of course. This tool should manage, of course, the context management. So the context management is important because, of course, when you are designing, for instance, Composer, you should not inject into the Claude Code context all things related to, for instance, BigQuery, Vertex AI, and etc. So only the important things should be injected into the context, not the whole, the whole structure. And what is important that whole documents like landing zone specification, architecture decision records, Terraform modules, organizational standards, CMDB, this can be in one repository. So this is possible that in the one repository you will have all the things, and you will pull this repository, and after that you will run Claude Code, and you will be able to start working both in the landing zone context or in the solution context. So this should be simple solution, because without that you will end up with a problem. We will end up with many agents that are doing this, but the complexity of this solution will be very high. And I want to show you that you can achieve this in simple way. So in the next episode I will show you all the things. And thank you for this episode, and I hope that you will learn a lot of things during the next episode. Thank you.